So, hello everyone. I am A.V. Sanjay from Sri Ramakrishna Engineering College. So, our capstone topic is Smart RGB Room Lighting using 8051 microcontroller.
Sriram from Ramakrishna Engineering College.
I am Srigaran from Ramakrishna Engineering College.
Hello all. So, this is our capstone project. The topic is Smart RGB LED Room Lighting using 8089 C51. So, me along with my teammates Sriharan and Sriram have done this capstone, and so starting with the aim, to design and implement a smart RGB LED room lighting system using the 8089C51 microcontroller that responds to serial input commands through a virtual terminal. So here comes the abstract. So this project is basically developed by a Proteus software, and here we are using the my 8051 microcontroller along with three LEDs, red, blue and green, and we are using a virtual terminal for the communication. So when the user types R, the red LED blinks. When the user types G, the green LED blinks. When the user types B, the blue LED blinks. So these signals are received through commands through a serial interface called the UART. So this circuit and code are designed and simulated using the Keil Vision 5 and the programming and Proteus design suite for circuit simulation. And here we are using two softwares. One is Keil 5 Vision and Philips Flash Magic software. So here is the block diagram of the circuit. So the virtual terminal is connected to the microcontroller 8089C51, and from here the LED red LED, green LED and blue LED is connected. So this 8051 microcontroller is the main circuit. So here is the program that we have executed in the Keil, and here we have used the cases for R, G and B, and here comes the program window where we have implemented this code. And when the circuit is powered on, the 8089C51 microcontroller initializes all required ports and the UART module. Timer 1 is configured in mode 2 and TH1 is loaded with 0 cross FD and baud rate of 9600 bps for serial communication. The SCON register is configured for 8-bit UART mode, and initial LED configuration is the RGB LEDs are connected to port 2, and all LEDs are initially turned off by writing a logic high to the respective pins, and UART data reception. The microcontroller enters an infinite loop for continuously monitoring the RI, that is receive interrupt flag. The RI flag is cleared manually after each character is read, and the characters are followed here. R is for red and G is for green and B is for blue. Toggle, when we press R, it toggles and the red LED blinks. Same for G and B. The toggle mechanism uses a bitwise NOT operator to change the LED state. So we have given two operations, one is on and off. So this toggle mechanism uses a NOT operator to change the state from on and to off. And the real-time LED feedback. The change in LED status is initially visible on the simulated LEDs in Proteus. This setup provides a simple demonstration of serial controlled RGB lighting, ideal for smart room lighting prototypes. And here is the result. We have pressed R and the red LED blinks. And we have pressed G, the green LED blinks. And in the next picture, we have entered B and the blue LED blinks.
Hi, this recording is about the schematic capture of our project Smart RGB Lighting using the microcontroller 8089C51. First, we are placing two capacitors side by side. Then we are connecting it with the crystal oscillator. Connect the pin 19 to capacitor 1 along with the crystal oscillator. Then 18th wire is connected to the crystal oscillator 2 and capacitor 2, and both the capacitor are connected sideways, and it is connected to the ground. It is shown now. Yeah, just connect it to the ground. Then and electric capacitor is placed, and the resistor is placed along with that for the minimal power supply to avoid fluctuations. And for this, we are using the pin 31 to connect the C3. Just rotate it as it convenience to pin it. And both the C3 and R1 is connected sideways using the same way, and the pin 9 is connected to the R1, and both are connected to a ground using a wire from R1 to the ground. And the power supply is connected to pin 31, which is connected to the C3 also. And we are changing the values of the capacitor to 33 PF. Then again C2 also is changed to 33 PF. And we are changing the values of the crystal oscillator too. Then changing the frequency value to 16 megahertz.
So now I'm gonna place the red LED, and now I'm gonna press green LED and place it over here, and now the blue LED, and I'm gonna place it over here. So now we have to rotate clockwise, and again do it for the green, and again do it for the blue. And now I'm gonna choose the virtual terminal. Where is it? Yeah, now I'm gonna choose ground. I've chose ground, and now we go for virtual terminal. Okay, paste virtual instrument, and then okay, virtual terminal, and I've got the virtual terminal. I'm gonna place it here. So yeah, I have placed it here, and now I'm gonna select a red LED and rotate clockwise, and again by mistake I've done that. And now okay, now I'm gonna connect the one edge of the red LED, and one edge of the green LED, and the one edge of the blue LED, and directly connect it to the ground. So done. And next I'm gonna place a resistor over here, and another resistor, and another resistor, each for red LED, blue LED, and green LED. So now clicking on to the R2 resistor, so 330, and okay, and again R3 resistor, it's in 10K, we have to change it, 333, I'm sorry, 330, and again the R4 resistor, it's in 10K, we have to change it to 330. Okay, done. So the other edge I have to connect it to before that. Okay, other end I have to connect it to R2, and other end I have to connect it to R3, and other end of the R4 to D3. And see, this Proteus is like a easy usable platform where people can directly access with the circuit and get their proper output. And now I have connected the R2 LED resistor to the P1.0, and I have connected the R3 resistor to P1.1 and R4 to P1.2. So this platform usually depicts a schematic circuit architecture where we can implement many software programs and run it online to get a proper, and we can test output results and all. And now we are selecting this, like let us adjust somewhat, and clicking on the LED. Let me give a space for that. And now connecting the virtual terminal to P3.1, that is 11th pin of P3.1, and TXD to P1.0, that is 10th pin of 8051 microcontroller, and RTS, we have to connect the RTS. Before that, wait, LED, okay.
This is the design we just plotted using the Proteus, and here is a 1851 microcontroller connected to the visual terminal of the pin 10 and 11, and it's a 3 LED, red, green and blue. It's connected.
So now I'm gonna press R, so the red light blinks. So now I'm gonna press G, the green LED blinks, and now I'm gonna press B, the blue LED blinks.